Hi, I'm DJ Ware. On this episode of the CyberGizmo, I'm going to be talking about openSUSE's MicroOS. This is a release candidate, and the one I'll be looking at today is the KDE desktop, which is in alpha status. Yeah, so why do we need this? What is the reason behind MicroOS? There's a trend that's going that is pushing towards more modernization of our distributions. The real thing that's going on here is that computers are no longer just laptops, desktops, and servers. I mean, we have Raspberry Pis, we have Pine 64s, we have NUCs, we have micro NUCs now. So people are no longer using just laptops, desktops, and servers, and they're certainly not using them the same way that they did 20 years ago, even 10 years ago. Regular Linux is just not good enough. I mean, the traditional Linux, it's like a Swiss Army knife. Yeah, it'll cut you. So anyway, it's lots of services and features. And with all of those services and features, there's an increased chance of incompatibilities between the services, but there's also increased chance of incompatibilities between libraries, between packages, between applications. And that increases the risk of complex failures that take time to figure out. You could spend hours trying to say, well, what the heck happened? I mean, everything was working fine, right? And then some security update that happened 2 days ago got into the system and completely made a mess of all the packages that were out there because of it. Yeah, and that has happened to me. I'm sure it has happened to you. openSUSE and MicroOS, it's predictable and it's immutable. Now, we've talked about immutability before. There are other systems, and we've talked about those. The one of the first ones was Fedora, and that they offered that initially in Silverblue, and then they offered a KDE variant, a Sway variant, and a Budgie variant as well. The reason for that is the root file system and the base operating system cannot be altered during runtime. So you can install all the packages you want, but none of them are actually going to appear until you reboot into the new environment. So that means that we at least have a chance of making things more reliable. We can automate our updates. If we have a problem during the update process, we can automatically recover by rolling back from a faulty update. It only needs a very small footprint in order to do this one job that it has. But it's a change. It's a change to the way we think about things. It's a change to the way we install things. Applications and services are expected to be containerized or sandboxed. So openSUSE MicroOS is a rolling release. It's based on openSUSE Tumbleweed. There is, however, an experimental version of MicroOS if you prefer to run Leap. MicroOS is wholly built by the openSUSE development team. In fact, it's the same group that does Tumbleweed. So it is developed and tested as part of the Tumbleweed release process, which means that if you find a bug in Tumbleweed, then MicroOS is prevented from release, and so is Tumbleweed. They're in lockstep. If they find the bug in MicroOS, it's gonna prevent the release of Tumbleweed until it's fixed. So I think that's a good plan. That's a good plan because now we have two operating system and two distros that you can choose from, that you can count on, that have at least been tested the same. That is, if you find a bug, it's going to be in the other one. The other thing is that MicroOS, unlike Tumbleweed, uses transactional updates. This deploys as part of ButterFS, so it's using the snapshot features of ButterFS to do it. Any change to the system can be applied reliably, reproducibly, and has a reversible course built into it that I can get back to a system that was known to be working. The transactional updates are atomic. And atomic means is that they have to commit before they are deployed. That is, If I'm installing a package that has, I don't know, maybe 10 or 15 other packages that are dependencies, and one of those dependent packages fails to install, I'm not left with a system that's halfway in and halfway out. Yeah, if you've ever been in that situation, all of a sudden you've got things breaking. In this case, because these are atomic, if one of those updates fails, it all rolls back. So it's either fully applied or not at all. So any bug, any problem, and it rolls out. It's applied without impacting the running system. You might need to roll back that release. Let's say it all the way went through, but it's not something you really had intended. Maybe there was a side effect that you didn't plan on or you didn't expect, and you don't really like the new behavior of the system. So you just want to chuck the thing, even though it said everything was fine. You want to roll back. I don't want to do this. I want to roll back to where it was working. So that allows us to play around with things without having to worry about breaking our systems, right? So now we can go in and we can try something new, and I don't have to worry about, whoa, what else do I need to uninstall 6 weeks from now? I'm done with it and I want to get rid of it. I don't have to go, well, what the hell did I install? And look at my log and I forgot to write something down, right? That happens all the time. MicroOS is a read-only root file system, and that raises a few challenges. It means that you have to reboot in order to install new packages. It also means your system is obviously going to be different after you reboot it. It also means that if you want to apply system-wide updates, you have to take the time to do that and then restart your system. Distrobox is similar to the way that Fedora does things on Silverblue. Both of them use Podman. Both of them are very similar in function, but I think Distrobox it has more of the features of Lexi than Toolbox does. Now, I say that, but a week from now, Toolbox could have those same functions in it. Distrobox pulls from, I don't think I mentioned this last time, it pulls from the Podman repos, the Docker repos, and the Lilliput repos. So any distribution that's any one of those three, you can pull into your Distrobox and use it as a container. So that gives you a pretty wide choice of distributions to work with. The main ones being Ubuntu, Debian, Fedora, and Arch. But there's more. There's Rocky. There's Alma Linux. There's Alpine Linux. There's all kinds of them. Even Linux Mint is in there. I think it's 21.2. Also, those come with their native package managers. You're able to use DNF for Fedora. You're able to use RPM for Fedora. You're able to use APT for Debian and Ubuntu, and Pacman and the AUR for Arch. So, and that means that your changes are persistent in that container between uses. So they're not ethereal. I mean, if I shut it down and bring it up, that's fine. It'll still have all the changes and all the packages I installed the last time I used it. So what do you need to run this thing? And one of the things you will see is, because this is a container managed system, it will eat into your memory very quickly. What do you need to run openSUSE MicroOS? Well, you need a 2 gigahertz or better dual core. I would say quad core would be way better. You need at least a gig of RAM, although you're gonna chew into that real fast too. If you're sitting on just the SDDM and you're accessing the machine through SSH or something, you'll probably find that it's going to be using about half a gigabyte of memory. But if you start up KDE, and that starts bringing up the infrastructure for Podman, it's going to jump into 2 gig real fast, and it'll go to 2.5 gig I think it's about a half a gig of memory per that it uses per container. You'll need about 5 gig of disk space for a minimal install. Now that means you didn't install a GUI. You just installed there's a minimal and a server variant of MicroOS. So that is referring to the minimal version. 20 gig for a graphical user interface, and probably more than that as you start putting applications on and actually start using it for something. 1024 by 768 is the minimum for the display. It's hardware. What about architectures? What can you use with MicroOS? Well, you can install it on x86, of course. It does support ARM in the 64-bit variant. So it'll run on generic ARMs that are 64-bit, Raspberry Pi that are 64-bit, so that would be the 4 and the 5. Pine 64 and PowerPC, if it's the PPC 64LE architecture, that will run. If you want to run this under a virtual machine, KVM, KMU, Microsoft Hyper-V. You can also use VirtualBox, VMware, Vagrant, Zen. You should be able to use XCP-ng because that's just a variant of Zen. So it should be able to run, although they just don't mention it. So that's why it's not on my list. With that, let's go take a look and we'll do an install. I'll show you some more advanced features than Distrobox in this. Okay, so I have a Proxmox VM set up, and I'm about to launch it. So let's go ahead and start it. And we'll go into the console. And it gives you can boot from the hard drive or do the installation. There's also more. We'll just take the installation step. Let me set this to scaling so it'll all fit on the screen. And then it should stop here, and then you can do a keyboard test if you want. Scroll down, go ahead and click next, and it'll go to await. It'll tell us what options are available to us. So we're going to choose this one right here. Then it takes us to a page that says, okay, we're going to wipe out that drive, and we're going to put 2 partitions on it and 10 subvolumes. Then we have, and this allows you, of course, to go back if you want to manually change something. And we'll go ahead and do an install. And this will take a bit, and I'll come back when this is done. Okay, as you can see, it's 9:07, and it was 9:02 when we started. So about 5 minutes to install, and now it's rebooting automatically. Then it will install a few packages. These are Flatpaks. This is Firefox. I think there's a couple of others that get installed along with this. What I'm going to do is, KCal. When this is all done, I'm going to do an update, a transactional update. And then I'm going to shut it down, and then I'll convert it over to running on Spice. That way we can get rid of this confusion at the bottom, because I don't want that being a problem for you. All right, so let's go to System. Let's go to Console, and I'll just blow that up a little bit. So what we're going to do is we're going to do a transactional update. And you just type in DUP, which is, it simulates a CD-ROM update. So that's what we're going to do. Give it my root password. Make sure you do this because the ISOs are snapshotted, and they may not have the latest version of the software on them. So make sure you do this before you start using it so that you pick up all the latest changes. As you can see, there's 192 updates on this one. All right, so I'm just going to shut this down. So what I'm going to do is, I have Distrobox here. And I can, now remember, we don't, if I try to do this, Yeah, it's not there. If you install it, you can try to install it through the transactional update, but it won't actually put anything in the man pages under user share. So forget it. You're not going to get anything. So yeah, I already went down that road. So let me just save you the trouble. So what we're going to do is we're going to do a distro box. I'm going to create. If I don't do anything else, it will create a tumbleweed distro box by default. If I want to create something of my own, if I want this, let's say we want Ubuntu and we want latest. And then we'll give it a name, and I'm going to just call it Ubuntu. And that's all I need. And then it should pull it from the repository unless you already have it, and then it won't unless it needs an update. Now the first time you enter on startup, so if I have rebooted the system, if I do, I'll just do a list here and you can see. So these are marked in orange, so they're not running. These are not running yet. They're just in a created state. So if I enter, it's going to install some basic packages. I have noticed that anytime you update your transactional update, and there are updates, it also will update only the packages that are used to manage the distro box inside the container. That would be things like the Distrobox export commands and some of those things, where it allows you to take an application and export the menu to your home system. Now, at the moment, I can do here. Let's make sure. And yes, we're in 2404 LTS, which is the latest. But I may need to update the packages. Well, let's do that. Nope, don't need to do anything here, so all good to go. On some of them, you may. Now, I think the man pages are here. No, this is the minimal version of Ubuntu. Let's do sudo. Oh, you know what? I haven't tried this. This will be interesting. That was it. Oh, look. Now I have man pages here. For Ubuntu, anyway. Let me just grab this and... So the first thing you're going to notice is that my environment from my host system is being shared. So if let's go ahead and install htop here. Actually, I think we'll just use top. Yeah, we'll just do top. They look identical, except the sort order is a little different. The other thing you'll notice is that root on the home system is translated to nobody. That's to prevent someone from modifying and gaining root access to your application space. But yeah, and so then I have my applications within here are shown as well within the container, but only the container shows out here. So your count may be a little bit different. I have 201. No, they're the same. 201. 1 running, 200 sleeping. So this is pulling from your host environment. So I'm not seeing just what's running on the container. I'm seeing everything that's running. So what if you want All right, we'll just leave this up over here. So what if I want to be able to create a truly local container that does not share anything with the host? Well, let me just show you that. So let's go to Distrobox, and I'm going to do a create, and then I'm just going to say, hey, what are some of the things I can do with the command? So first off, it shows you some usage and where you're pulling from. So this will show you, which ones are available. The image is where you pull the image. What's the name of the image you want? There's currently images from Alpine, Alma Linux, Rocky Linux. Yeah, there's probably others as well in here that you can look at. So I'm interested in this down here. This is the what you share and what you don't. So if I can mark out that I don't want the devices or the sys directory shared from my host. I can unshare my groups. I can unshare my IPC namespace, the network namespace, the process namespace, or I could just say I don't want anything. I don't want any of those. I want all off. So let's do that. Let's create. You have to do this at the time that you create it. So and we'll give it an image. Let's say, well, hey, let's do it this way. Let's just do a name. We'll let it do. We'll let it do tumbleweed, and we'll say. I'm going to unshare all. So now it's pulling openSUSE. All right. The same thing where it has to do this again. And it still gives me this container box here to let me know that I'm in the container. And it also updates my tumbleweed out here. So, okay. So now if I run a top, oh, I'm not seeing all those anymore. So this time I'm only able to see what's running in my container. Also, it created a custom dev list of devices that my container has described. So yeah, so this is running inside of a VM, so it doesn't get to see all of them, only the ones that are default for creating a container under MicroOS. So yeah, we obviously do not have the same devices as we do over here. So that's good. Now I don't think there's anything to see here. Nah, yeah, okay. So I do have some semaphore arrays and I have a shared memory segment on the host, but I can't see those. So this is good. So I was, able to actually show this, and that's a good thing. So yeah, so none of your shared memory segments are available to the container. So you are isolated pretty much. There's some downsides to this, but yeah, if you want the container to run completely self-contained, you can do that. Let me come back and I'll do my final thoughts here. I'd like to take a moment and thank the sponsors of this channel, the members of Patreon, as well as the members of the channel through YouTube. Thank you so much for your support and helping bring this content in a higher quality than it would be possible otherwise. So what do I think about MicroOS? Well, first of all, I thought, being that it was called MicroOS, it might have a microkernel operating system, and so no, it doesn't. It is the same kernel that you get from any Linux distribution. It is a fully developed kernel. So, and I thought that, well, darn, well. The reason it's called MicroOS, I guess, is because they felt that it was more modular than other distros are. It really is dependent upon containers. Now, you can install this without a GUI. There are two versions of it. There's a minimal version of MicroOS, and then there's kind of a server version of MicroOS. There's also a cloud version. I'm not sure what's in that one. And there's also the ability to do what they call combustion and ignition. So those are two separate processes that allow you to set up your systems ahead of time. So you can go in, you can edit, like in the case of combustion, that's a bash script. In the case of ignition, that's a lot easier. It's just a file that you can go in and modify. Are they different enough that that one is better than the other? I couldn't really determine that. It didn't look like that was the case. It looks like they have set this up for various levels of expertise. So ignition would be for people that aren't making full-blown changes to the operating environment, but they just want to bring up something in a cloud environment, cookie cutter that, and then repeat it for as many times as they need. The same is true of combustion, but combustion is more detailed. In other words, it can do more, and it requires more expertise on setting up the system. So it is a level of granularity below the ignition. So if you're interested in that, they have a whole set of guides out on the MicroOS site that go through it. They explain it. There's even a set of videos that will walk you through the steps on how to do that. I am not going to go through that today. Yeah, if it's something that you'd like me to take a look at, let me know in the comments below, and I will take a look at that and see what we can do. I've only been running this for about a week, so yeah, it's not enough time, and I'll probably come back and talk about it in the future and let you know, hey, these are some things I ran into with it. And this is how I fixed it. So yeah, anyway, that's all I had for today. I hope you enjoyed this video on MicroOS. All in all, I think it has potential. There's some things I like. There's some things I don't like. But hey, all software is imperfect, so you can't expect perfection. I'm not judging it. It is an alpha that is for KDE. And yeah, you can read all about it on their pages. They'll tell you why it's an alpha, what some of the bugs are. And yes, I have seen those bugs. So with that, I hope to see you all again in the next video. And bye for now.